All right, example 52. Examples 52 says if f of x is equal to 2x plus 2, if x is less than or equal to 3, but greater than or equal to minus 1, and f of x is equal to x squared minus x plus 1, if x is less than or equal to 5, but greater than or equal to greater than or equal to 3. So we can essentially see that this function is defined between x is equal to minus 1 and x is equal to 5 inclusive. All right, so let's find f of 0. First of all, 0 is between minus 1 and 3. So when x is equal to 0, f of x is defined as 2x plus 2. So f of 0, wherever I see x, I'm going to put 0. 2 times 0 plus 2 is equal to 2. So f of 0 is equal to 2. Next, we're asked to find f of 3. Now, notice that when x is equal to 3, f of x is defined as 2x plus 2 as well, because f of x is equal to 2x plus 2 when x is less than or equal to 3. So when x is equal to 3, f of x is equal to 2x plus 2. And so f of 3 would be equal to 2 times 3 plus 2. So this looks like 8. All right, next we're asked to find f of 1. Now, if someone asks me to find f of 1, the first thing I would find is f of 1. All right, f of 1 is between what? 1 is between minus 1 and 3. So when x is equal to 1, f of x is equal to 2x plus 2. And so f of 1 would be equal to 2 times 1 plus 2, which is equal to 4. So what this essentially means is that f of 1 is the same as saying f of 4. So to find f of 1, I must find f of 4. Now, when x is equal to 4, f of x is defined as x squared plus what? Minus x plus 1. So f of 4 would be what? 4 squared minus 4 plus 1. This would be 16 minus 4, 12 plus 1, which is 13. All right, so example 53 says the graph of a piecewise function is given below. We're to write a definition for a function or for this function. So what you'll notice is that this graph has 2 parts to it. Both parts are linear graphs. So let us say this is part 1 and this is part 2. So in both cases, both graphs intersect the y-axis at the origin. And the format of all linear graphs that pass through the origin is this. Y is equal to mx is the form of all linear graphs that pass through the origin. In other words, to determine the equation of a linear graph that passes through the origin, All I need is the gradient. In other words, if a linear graph that passes through the origin is defined only by its gradient. So we just need to find the gradient of the first half of the graph and the gradient of the second half of the graph. All right, so for the first half of the graph, I have 2 points, -2, 4, and 0, 0. M, the gradient, is equal to what? Y2 minus y1 over x2 minus x1. So this would be 0 minus 4 over 0 minus -2. So for the first half of the graph, the gradient is -4 over 2. So the gradient M is equal to -2. That is important. Now for the second half of the graph, 2 points on the graph are 0, 0 and 4, 6. M, the gradient, I need the gradient. M is equal to 6 minus 0 over 4 minus 0. The gradient is 6 over 4 or 3 over 2. All right, so what does this mean? It means, therefore, that f of x is equal to minus 2x if x is what? Less than or equal to 0, but greater than or equal to minus 2. And f of x is equal to 3 over 2x if x is less than or equal to 4, but what? Greater than or equal to 0. So that would be your definition for the function that is defined, that is what? Described by the graph above.